Hey guys, today we will be making a custom action logger as I already mentioned in my last video. I'll place this logger anywhere in the code where I think the action is crucial or can affect the business in any way. This way we'll know what our fellow staff members, the ones we've given permissions to, are up to. It's not something that will monitor their networks or track any of their private histories. It only records the action or command they give to the database. In other words, it's like a history map that makes members accountable if they ever try to sabotage something or make harmful changes. Not a big deal. Here's how it looks at the end. Of course, you won't be seeing everything up to this point in this video, maybe in later videos. For now, let's see how it all started. So as I explained in my previous videos, when using AI tools like Copilot in your code, try documenting or commenting first before starting the actual function. Describe what you want it to look like. That way, when the AI is suggesting, it already knows what you are aiming for. This, of course, is for auto-completion suggestions, or whatever it's properly called. Now, look at this repetition of code here in SQL. The bind, the fetch, checking if there are results, and so on. To me, that's a lot of repetitive work. So in later videos, I'm going to change all of this by adding a custom database class that will handle all these steps with just a single line. All right, let's get straight into it. Here's the final version of the class we've been building. If you look closely, you'll notice two things. I renamed the class, and I also made the database changes I mentioned earlier. The most important piece here is the query function. This function takes care of everything, running SQL queries and giving us back the results we expect. Whether that's an insert ID, an array of rows, or just true-false, the query method has us covered. Now let me break the class down step by step. We start by defining two key variables, DB, which stores the database connection, instance, which stores the class itself so that we can use it in a singleton pattern. Inside the constructor, we set up the database connection. That means as soon as we create an instance of this action logger class, it already has an active connection to the database. Below that, we have the getInstance function. Here's what it does. If the class hasn't been initialized yet, it creates a new instance. If it has, it just returns the existing one. This is exactly what a singleton is, a single shared instance of a class. But here's a word of caution. Singletons aren't always the right choice. For example, if you're building a user class which deals with constantly changing data like usernames, emails, or profiles, you don't want to lock that into a singleton. Otherwise, you risk working with stale data unless you carefully update everything with setters. So use singletons only when the data is meant to stay consistent. Now moving on to the helper functions. These are pretty straightforward. Methods like delete log, delete logs, delete all logs, delete logs by group, and so on. They handle log management in the database. Earlier, I mentioned I'd build a separate helper class to handle all database executions. That's where this query function actually comes from. Let me explain what it returns. On a select, you'll get an array of rows. On an insert, you'll either get the insert ID or true. On a delete or update, it returns true, false, or the number of rows affected. This way, my code becomes super clean. I just call query once, and the helper class takes care of everything behind the scenes. Now, I know what some of you are thinking. Pascal, this is great, but what if someone has access to the activity page and deletes their logs to cover their tracks? Good question. Here's how I handled that. Every time a delete log action is triggered, we back up the log to folders outside the root access of the system. That means even if someone can access the whole application, they won't be able to find or tamper with the backups. The only way they get to it is if they had access to the actual hosting server. And if that's the case, then wouldn't the system already be compromised? So yes, the logs are safe. That wraps it up for this session. I think the class turned out really clean and efficient. Let me know what you think down in the comments. And of course, don't forget to like and subscribe for more of what I've discovered and learned so far.